All right, this is 3.1, Properties of Exponents. So there's all of your properties from Algebra 1 and including Algebra 2, where if you have a fractional exponent, the nth root of a to the m, that's a to the m over n. So remember, a square root is x to the 1/2. All right, so let's just get started here. In example 1, this would be 2 to the third x to the third times 3 to the second x squared to the second. So that's 8x cubed times 9 times x to the fourth. So that's 72x to the seventh. All right, I have two negatives, so that's going to be a positive. 88 over 8 is 11. And then be careful. You are subtracting a negative 3. So that's 11x to the 13th. Okay, in letter C, there's several different ways you can tackle this one. I personally like to simplify what's inside. So that's negative 5. Now that's going to be x to the negative 6, because that's negative 8 minus a negative 2, okay? So be careful with that. Then when you have, I'm going to kind of do this in parts, and this might not be the most efficient way, but this is one way to do it. So that's negative 5 to the negative third. And then I have x to the 18th, and then that's going to be a negative 125. Or you can put the negative up in the top, like that. Okay, on this one, the first fraction just stays as it is. The second fraction, if I'm going to raise everything to the second power, don't forget that 3. All right, then the z to the fourths cancel. I do end up with a 9x to the sixth. Now, you have y to the sixth over y to the fifth. So that ends up being 9x to the sixth y over 2. All right, then in this one, we want to state whether the equation is true or false. This one is false. There is no property that says if I have different bases that I can do that. Yeah. So then in this one, you have false. This is a PEMDAS error. You have to do the exponent beforehand. On the left, this one's false because you don't cancel the 4s. You use the exponent, the quotient property. This one is 3 over 4 times 10 to the 16, which is 0.75 times 10 to the 16, which that is true. That one's a true. All right, then in example 3, it says evaluate each of the following. 36 to the 1/2 means the square root. This one is negative 1 times 2 to the 0. So that's negative 1. In the third one, this means the fourth root of 16 cubed. So that's 2 cubed, which is 8. This one means the cube root of 27, which is 3, and you square it, is 9. All right, then in this one, you want to see if you can get the same base. So the bases are equal, so then that means their exponents are equal. So in this one, x is negative 1. All right, just to remind you, 4 squared is not 8, so 2 cubed is 8. So then that's a power to a power, so you multiply the exponents. I am not canceling the bases. I want to make sure that's clear. I'm not canceling the bases. I'm getting the bases equal. If the bases are equal, then that implies that their exponents must be equal. All right, in this one, 3 cubed is 27, and 3 to the negative 4 is 1 over 81. So I can get a common base of 3, then their exponents are equal. All right, in this one, this is 7 squared over 3 squared. And if I flip this, so then I can make that so that they have the same base. Then this is 7/3 squared to the x. So I can just multiply there. So 2x is negative 3/2. So you divide by 2, so x is negative 3/4. All right, so in this one, I want to do this with an example. So if I let x be negative 3, so I take negative 3 squared, which is 9 to the 1/2, that's 3. So here's what I want you to gain from this. You've got to be careful when you are taking the square root of x squared. It's actually equal to the absolute value of x. So just be careful with that. All right, so now let's do the equation solving, but we're going to take it up a notch here. So 1/3 is 3 to the negative 1. 27 is 3 cubed. 9 is 3 squared. Now be careful here. This is 3 to the negative x minus 4. This is 3 to the 3x over 3 to the 2x minus 2. So this one's taking a little bit more effort. So when I subtract, I'm going to get x plus 2. So now I can set the exponents equal. So x is negative 3. All right. In letter B, 16 is 2 to the 4th. 8 is 2 cubed. 1/4 is 2 to the negative 2. So then let me multiply my exponents. All right, now I'm in a position where I'm going to add the exponents. And now I can set the exponents equal. So I'm getting x is negative 8. Okay, there you go.